Okay, Assalamualaikum warahmatullahi wabarakatuh. And how are you? Today is our week six, right? And this is our chapter 5. This is about the strategic capacity planning for product and service. Okay, when we hear this title, strategic capacity planning, so we want to design our capacity and our capacity production is in the good conditions and optimum. It cannot be too much or too low. If too much, it will make a cost, and also if too low, we will problem with our customers later because the customer demand is always run and our capacity is not enough, so it's not good for too low. Okay, actually, this is my second recording. Before I already record, but no sound. I forget to set the sound, and we will continue. Our class is about the strategic capacity planning for product and service. Okay, let us try. Okay, capacity planning is actually how we plan our capacity is still under control. I mean, in the optimum conditions. The upper limit or ceiling on the load that operating unit can be handled. And also the capacity needs include the equipment, space, and employee skill. So upper limits means we should know the conditions or the maximum capacity of our production. We cannot make it too much, and also we cannot make it too low. The the production because it will affect to the cost and also the demand of the customers. Too high or too much productions, okay, we cannot control the cost. But if too low, also we have a problem with the demand of the customer. So the capacities needs include the equipment, space, and employee skills because equipment can make our capacity handlings. I mean, the production handling is quite good, and also the space of the production is need to be calculated. Yeah? If the space is too small, so it will make effect to the capacity planning, and also the employee skills. The good skills will give us the good productivity and also will give the impressions for the production. Okay, the strategic capacity planning. Okay, the goal is to achieve a match between a long-term supplies, the capabilities of an organizations, and the predicted level of long-run demand. Overcapacity will make costs, and undercapacity strains and may make our a loss of the customer that I told you before. Yeah. So we make it faster, yeah, because the slide is quite uh, many, the number of the slide. Okay, capacity planning questions. So what kind of the capacity is needed, and then how much capacity is needed? We need to calculate it, and then when it is needed. So we need to know the uh, when the productions, the number of productions that we need to make in the company. So we need to determine when, yeah. And then another question is how much will it cost? What are the potential benefit and risks? Are the sustainability issues? Should capacity be changed all at once, or through several small change? Can the supply chain handle the necessary change? So, but the sustainability issues is about the environment, social, and economic impact. So we need to identify if our production is too much, so it will affect the economic because it's cost, environments. Of course, it will make some weightings for productions. For example, the distribution also will affect. When the distribution is affected, so it will affect the environment, pollution, and so forth. Yeah. Capacity decision are strategics. So the capacity decisions will impact the ability of the organization to meet the future demands. Okay, we need to make a good decision for this. Effect operating costs. Of course, we need to consider how much the productions should be produced at in the specific time, or major determinants of initial costs often involves long-term commitment of resources and can affect the competitiveness, affect the ease of management, and are more important to and complex due to the globalizations, need to be planned for an advance due to the consumption of the financials and resources. So this is the capacity decisions are very strategic. The the benefit of good capacity decision, yeah. And then the capacity need to we need to first consider the design, the capacity, and then we need to consider the effective capacity and the actual output, the capacity. For design capacity, we need to know maximum output rates of the service capacity and operations process or facility in the designs. And also for the effective capacity, the design capacity minus allowance such as the personal time, maintenance, and scrap. Okay, and then the actual outputs, like rate of output actually achieved and cannot exceed the capacity, effective capacity. And to measure the system activity, effectiveness, so we need to know first the actual outputs, the rate output, the actual achieved, and it cannot exceed the effective capacity. And we need also to measure the efficiency, and it can be measured by the actual output divided by the effective capacity. And the utilizations. This is the actual output designs over the design capacity. Okay, this is the example. For the example, design capacity for 50 trucks per day, okay, and then the effective capacity is 40 trucks per day. Then the actual output is 36 trucks per day only. So the efficiency is the actual output. The actual output here is 36 divided by the effective capacity. Okay, effective capacity is 40. So the efficiency of these, the utilizations, the efficiency of this truck design capacity is 90%. Okay, then the utilization is the actual output over the design capacity. The actual output is here is 36. Okay, and then the design capacity is 50. So 72% of the utilizations for the capacity. Okay, this is the exercise. Last week, the facility produced 148,000 rolls. The effective capacity is 175,000 rolls. The production lines operate 7 days a week with 3 8-hour shifts. The line was designed to produce at a rate of 1,200 rolls per hour. So compute the design capacity, and then the second is the utilization, and then the third is efficiency. Okay, the design capacity is we need to multiply by all the days, multiply by all the shift, and also the number of hours, working hours. Here we can see 7 days, 3 shifts, and 8 hours is the continuous productions. Okay, working 24 hours. Multiply by 1,200 rolls per hour, and then we get the 2,000, 200,000, 1,600 rolls. And then the utilizations, we get the number of we just calculate by the actual output over the design capacity, and then we get the 0.8%. And then the efficiency, actual output over the effective capacity, and then we get the number of 84.6%. Okay, determinants of the effective capacity. We need to consider facility, product and service factor, process factor, human factor, policy factor, supply chain factor, and external factor. This all factor is very important in the capacity planning. Yeah, sometimes human factor, when the humans has problem, also process factor has a problem, supply chain issues, external factor, it will affect to the plans capacity planning. Okay, capacity strategies. Okay, it's considered of three aspects: leading, following, and tracking. Leading is build capacity in anticipation of the future demands increase, and then the following, build capacity when demand exceeds current capacity. And then the third is tracking, similar to the following strategy, but adds capacity in relatively small increment to keep pace with increasing demand. Okay, strategy formulation. In the strategy formulation are typically based on the assumptions and prediction about first long-term demand pattern. Okay, when we see the demands for long-term, we can see the pattern, yeah. And then the technological change, competitor behavior. This is very important when you want to predict the capacity planning. Okay, when the competitor behavior, we can identify goodly, so we can make a good planning for our capacity. Capacity cushions is the extra capacity used to offset demand uncertainty. The calculation is capacity cushion is 100% minus utilization. Okay, the capacity cushion strategy is organization that have greater demand uncertainty, typically have greater capacity cushion. And also the organization that have standard product and service generally have greater capacity cushion. Okay, bottleneck. You know bottleneck? Bottleneck in bahasa Melayu leher botol. Leher botol. So capacity analysis, we need to identify the bottleneck, involve determining the throughput capacity of workstations in system, and bottleneck, an operation that is limiting factor or constraint. For example, here you can see the highest number of the production is in the what is this, station 7. So this one is 15 hour, 10 hour, 20 hour, but this one is 34 hours. Yeah, 34 hours. So it's not quite good. Yeah, very high number. So we need to make the line, identify the bottleneck, and then we need to focus to how we can make the system run smoothly. If we already know here is the bottleneck, we can prepare the strategy to minimize the bottleneck. Theory of constraint. Identify the constraint, develop a plan to overcome the constraint. Focus resource to accomplish in the step 2. Reduce effect constraints. When one step is overcome, return to step 1 and identify the new constraint. You can see here, starting from 200 pieces per hour, become 180 pieces per hour, and then reduce again. Okay, starting from here to here, reduce. We need to identify what is the problem. Yeah, sometimes the problem is in the what is that, the employee or the worker. Okay, sometimes from the supply of material problem, so we need to identify it. And after that, recalculate it again, and then we try to supply the material. For example, maybe this one, the problem is material, right? Okay. then continue, and then the station D perform better, and then the E also perform better. Step in capacity planning. Okay, estimates, yeah, the future capacity requirement, evaluate existing capacity and facilities, and then third is identify alternative for meeting requirement. Then four is conduct financial analysis, and then assess the key qualitative issues. Wait. Select the best alternative for long term, implement the alternative chosen, and monitor result. Okay, forecast capacity requirement. It consists of long-term consideration relates to the overall level of capacity requirement, so long-term and short-term. For short-term, the considerations relates to the portable variation of the capacity requirement. And then the calculations of processing requirement. So you can see here the number of requirement machine we can calculate by standard processing time, the sum of the standard processing time multiplied by demand, and then over the time available during the planning horizon. Service capacity planning. So we need to identify three kinds of the service capacity planning. Okay, first is the need to be near the customer, make the customer convenience for us from our company. And then the second, the inability to store service. Cannot store service for the consumption later. Okay. And then the third is the degrees of demand volatility. And then this is about the volume and timing of demand and time required to service the individual customers. The demand management strategies used to offset capacity limitation and that are intended to achieve a closer match between supply and demand. It's about the pricing, promotion, discount, and other tactic to shift the demand from peak periods into slow period. The in-house or outsource. Okay. Wait. Okay, we'll make it faster. Just slightly read to you. In-house or outsource. One capacity requirement are determined. The organization must decide whether the product produce a good or service itself or outsource. Factor to consider. This is the available capacity, expertise, quality consideration, the nature of demand, and cost risks. And then developing capacity alternative is also important because we need to things that can be done to enhance the capacity management. It can be achieved by design flexibility, take stage of life cycle into account, take a big picture approach to capacity change, prepare to deal with the capacity chunks, and attempt to smooth capacity requirement, identify the optimal operating level, and choose a strategy if expansions is involved. Okay, the optimal operating level is we should see where is the minimum cost and also the optimal output rate based on the rate of the output. See here, the minimum cost is in this position. So we just make a line here and we can find is the lowest minimum cost in this condition. So we can check this is the optimal rate output. Okay. Economic scales. If the output rate is less than optimal level, increasing the output rates result decreasing average per unit cost. Reasons for economic scale: fixed costs are spread over a large number of units, and then construction costs increase at a decreased rate as facility size increase, and then processing costs decrease due to the standardization. Okay, these economics you can read here. If the output rate is more than optimal level, increasing the output rates result in the increasing average per unit cost. This is the reasons for this economic scale. Distribution costs increase due to the traffic uh, congestions and shipping from the central lines facility rather than multiple smaller facilities, and the complexities increase costs. Flexibility can be an issue in an additional level of B accuracy. Okay, same like before, yeah. We need to identify the facility size and optimal operating level from small, medium, and large. Same like before, we need to identify the what is the lowest cost for the small plan. Okay, you can see here, medium plan and then the large plan. Identify the minimum cost in each plan. Yeah. Constraint management constraints some that limit performance of process system in the achieving its goal. Its categories like market resources, material, financials, knowledge of competencies policies. Resolving the constraint issues, identify the most processing constraints, change the operations to achieve maximum benefit, and make sure the portions of the process are supportive of the constraints. Explore and evaluate ways to overcome the constraint. Repeat the process until the constraints level are at acceptable level. Okay, evaluating alternative. Alternatives should be evaluated from varying perspectives. First, economic and economic, non-economic. First, economic, cost of value analysis, financial analysis, decisions theory, waiting line analysis, simulations, and non-economic. Public opinion for non-economic. This is cost value analysis, fixed cost, variable cost, total cost, and total revenue, or TR. For fixed costs, it tend to remain the constant regardless of the output or the value. And then the variable cost is very directly with the volume output. And then this is calculated by quantity multiplied by the variable cost per unit. For total cost, this quantity multiplied by the volume, yeah. And then the total, variable cost per unit V, yeah. Total revenue is revenue per unit R multiplied by the quantity. Break-even point. Okay, break-even point. Wait. Okay, you can see here the break-even point is the point that the volume of the output which total cost and total cost revenue are equal. You can see the total revenues minus the total cost is equal with, okay, this equation, yeah, you can read and then you can try later by the example, you can check in the book, yeah. Cost value relationship, you can check also here, consists of several kind of the cost value relationship. Okay, this is the fixed variable and total cost relationship. Yeah, this one is total revenue increase linear with the output, yeah. And then this is the total revenues minus the total cost. And then we can see here, this is the total cost, this is the profit, and then total revenue. Here is the loss, yeah. When we meet it here, we can identify the loss here. And then the break-even point, yeah, which where is loss and where profit, we can check in this middle as our break-even point. And also for the point in indifference of the indifference for two alternative. This is profit from the alternative A, this is profit from alternative B. So we can see the correlation. Here has the intersection as the volumes, our Q volumes unit. I mean, sorry, for the point of indifference between alternative A and alternative B. Cost variable analysis assumptions. So cost variable analysis is a viable tools for comparing capacity alternative if certain assumptions are satisfied. One product is involved, and then everything produced can be sold. The variable cost per unit is the same regardless of value. Fixed costs do not change with a volume change, or they are step change. The revenue per unit is the same regardless of volume. Revenue per unit exceeds variable cost per unit. Financial analysis. So it is about the cash flow and present value. The difference cash flow is the difference between cash received from sales and other source and cash outflow for labor, material, overhead, and tax. And the tax, okay, sorry. And then the present value is the sums in current value of all future cash flow and an investment proposal. Financial analysis, I think same like before this one. Okay, assembly line balancing I explained in the another slide, yeah, in the second slide. Okay, thank you very much. You can continue for the next watching slide, yeah, video in my YouTube. Thank you.